right. So that was it for my updates. And thanks everyone for all the feedback. So then let's see. Next, Scott, I think you had an update on the course you've been working on.
Yeah, I've got it built, and I neglected to take some pictures, but maybe next week I have some pictures. I have it built, and I think it'll work out good. And basically, you'll be able to put this thing together with no tools. It basically plugs together and folds up into 4 different pieces. So, like I said, hopefully I'll have some pictures soon. I ran out. I've been painting it, and I ran out of spray paint today, so I'm gonna have to go get some more spray paint. But it's almost done. I was gonna try it out, check out CanMan, and see if it still works when I get it going. So hopefully I'll get some video. And I like your idea of the time lapse thing. I'd like to shoot a time lapse video of tearing the thing down and setting it back up to kind of show everybody how easy it'll be. You know, the one we have now has all the wing nuts and, you know, all the splices and all that. And so this one will be a lot easier and it'll be a lot straighter. So
I can help you with the time lapse stuff. I mean, for a something that takes 5 or 10 minutes, that's easy to do. The thing I struggle with is because I mean, these modern phone cameras are remarkable. You can put on a tripod and you're almost done. The struggle for me is when you got something that has to last years and you want pretty much the same view over years. Then that's another
something you can dedicate to that purpose.
Yeah.
I bought these little they're little video cameras, but then there's another trigger line where you can take a snapshot from it.
Yeah.
And I actually have one on CanMan, and I've taken like some first-person videos of the Can contest with it. You know, it's nothing special, but has a little SD card in it. But I always thought that it, with a timer or like Ray was suggesting, or maybe John was, kind of put it on a timer or a motion sensor so that whenever there's motion, it just clicks picture, or, takes a video and you just swap out the SD card and keep downloading it. And then you just take out of it whatever you want. You accentuate some processes, because every 10 seconds or every minute, for some processes may not be enough. Right. So you may think about, being able to change that frequency depending on what you're doing.
Just to clarify, that motion app doesn't need a motion sensor. It starts capture based on changes to the video feed, the video
image. Yeah.
Interesting.
So you're going to do it like claymation, the engine's going to like appear and then, climb out over the hood. And,
that would be fun.
Are we going to get Carl and Gromit? Is that what I'm hearing?
Carl and Gromit. That's
Carl and Gromit.
I like it.
Don't know the reference. What is Carl and Gromit?
It's a claymation cartoon. It's
really fun one.
I'm 4 years old. Like one of my new favorite sayings is, "What's the point of being an adult if you can't be childish every now and then?" So, that's why I know a lot about cartoons and stuff, and all that kind of stuff goes on there.
I think the last claymation I saw was, God, he got a lot of flack for it. God, now I can't think of his name. Eddie Murphy. And he did the, oh God, it was like, I'm assuming like in Chicago, it was, subsidized housing, and, Thurgood was one of the main characters. He was like the caretaker of the, of the high rise, and he had his wife. And I remember one of the episodes, his wife got a cold, and, he was taking care of her. And so there's this like pile of Kleenex at the end of the, used Kleenex at the end of the bed because she's got a really bad cold. And his comment was, man, I would never have thought all that stuff could have come out of that cute little button nose, you know? So, but, you know, pile of snotty Kleenexes.
Ray, if you haven't seen Wallace and Gromit, though, the early ones were really cool. Yeah. He did one about a dog, too. What was, you guys, or not a dog, a sheep, Shaun the Sheep. But I don't like those as much as I do the original Wallace and Gromit.
Huh. So what time frame were those?
Well, Shaun the Sheep is, I think,
like 80s, 90s?
No. Shaun the Sheep is pretty recent, but Gromit, Wallace and Gromit is probably 2000. I'm just guessing. I'm just guessing.
Huh.
Yeah.
So.
Oh, do I see? Are we getting a demo tonight? Does anybody know? Same Jack over there fumbling around on the backside.
I haven't heard. So I think we're out of official cues. So, and if somebody else wants to jump in, this is a good time. Or otherwise, just open mic.
Could I throw in something impromptu?
I show you my, you know, I kind of broke this out last time I was on. It had a little 308, you know, Ecoleo board on it, and I blew that up. So I had this other board here. So I've got quite a bit more horsepower. I've got one of these. It's like H723. I think it's good for like up to 500 megahertz.
Oh yeah.
So I've been putting the hardware together, but I actually had the software working on the little board, the little 308 board. And then I was going to add another sensor to it. And I took my metal ruler and I was going to measure how big it was going to be. And then it stopped working after that. So had kind of a setback there, but.
It was the last measurement you ever made on it, huh?
Yeah.
The one he blew up must have been his Mad Max robot.
Yeah, well, you know, I kept trying to fit into that Arduino pinout footprint because I had the H bridge that plugged on top of it. And I kept having to move things around and there wasn't a lot of options on the pinouts on that little 308. So this other one here, it's got plenty of pins and plenty of options. So I told my wife it's like the Tim Allen version of this robot. Extra horsepower. So it doesn't do anything at the moment, but still working on that.
I think, didn't Cooper have something he was going to say?
Yeah, if y'all don't mind, I was gonna try and raise my hand, but I was sitting on the floor earlier because I couldn't find a socket there. I got something real small, real impromptu.
Cool.
If y'all.
Yes. Yeah. Bring it on. Bring it on.
That, yeah. I don't mind that I've just got my calculus homework that I've got opened up on some of that. So you haven't seen me in a while, or at least some of y'all haven't seen me in a while. Last time I presented independently from Iron Rain, I presented this, I think, or maybe it was the one before it even. I've been working at this for a while. So basically just for, God, as long as I've been into robotics, I wanted to make a robotic arm, something that I could just have at my desk as a, I think way back when I used to call it a research tool. Now I know that it's just a toy. But in any case, it would be something that I could use as a portfolio piece when looking at trying to get into industry. And so I catted up, a bunch of different ideas for robotic arms. I started very basically with just these, NEMA 17, just like throwaway motors that I got from somebody's old maker bot. And that was, before I learned about, torque and how, the whole, you have to have so many teeth mesh with a tooth with a toothed gear with belts before, it's like slippage and whatnot. In any case, I've tried at this a couple times. I can't say I've ever built one of these. It's always a matter of I get a really nice design going, and then the funding issue hits. Here, this is what I was trying to open earlier. So this was my design before my previous design. I'm not going to move ahead with it just because I don't know if it really kind of fits my goals with this type of project, but I'd like to briefly go over it just because I think it's cool. So I was trying to design this one with cost effectiveness in mind. So I used mechanical multiplexing to reduce the number of motors that I need for the arm. And I guess I don't know if this is really particularly used in any other types of like industrial robots. But in theory, right, you would have this linear slide with a NEMA 17 style motor controlling a linear actuator, or what's the barbershop pole kind of thing. It would push this
like on a screw.
Yeah, like a screw.
Yeah.
It would push this whole thing back and forth, where it would interface with these little, I don't know what you'd call them, but they'd, I guess motor interfaces really. And it would, interface with this one brushless motor. So you'd only need one brushless motor to drive both segments, right? Well, I guess one brushless motor and the NEMA 17 motor. Those would go into worm tooth gearboxes because I kind of thought that I gotta remember how that.
Right, if you have like a tension on something and you don't have it being held like by a worm and worm gear mechanism, it'd just fall down.
Yeah, exactly.
Yeah.
But with this, since it's not back drivable, it would, in theory, keep up the entire. Here it is. Keep up the I've lost my place here. I'm sorry. It would keep up the entire body. Wow. There it is. Can't read. The thought was this was all maybe 3/16 inch aluminum. And it would be using a bunch of like off the shelf, these are Go Builda stock axles or whatever. This was the part that I found maybe the most interesting about this design. And this was something I'm curious to see if anybody's ever tried with the whole kind of trying to save costs. So this is, I forget the term, but basically this axis right here drives both segments in which, so the motor would, interface with this gearbox, which directly went into this axle, which drove this first segment, right? This model's a little off. There shouldn't be these collets here, what have they called their shafts, couplers? There should be bearings in these because the idea is that the motor would multiplex up to this other, gearbox. This would drive this shaft. There would be a belt between this, this sprocket and this sprocket, and then these would be mechanically coupled such that there would be a belt that could run from there to there. So when you spun this, it would spin, this, if that makes any sense.
Yeah, so Cooper, way back in like the 1980s, Radio Shack came out with this toy robotic arm that had, I think it had one motor in it and a whole bunch of gears. When you press the levers and stuff, it would move the gears around to engage different parts of the arm to move different parts. But I think there was only one motor in it.
Mm-hmm. I think I've seen James Bruton recreated something akin to that, but I believe he used clutches, maybe?
Yeah, possibly.
Could be.
Or maybe it was, like multiplexed, but the multiplexer was just that lever, where you would engage different gears based off the lever position. It's been a while since I had seen that, but I do know exactly what you're talking about. Reminiscent too of older toys. This kind of looks, at least to me, like a Rector set a little bit.
Yeah.
One of the things I was a little curious about, so I'm trying to work on with my modeling. You can see that it's very much derivative of like I fall into the trap of using plate, and then just kind of doing that whole thing, because in my mind, I'm very much, or I've had a lot of experience modeling for 3D printers and CNCs, or like a 2.5D CNCs. But I don't quite know how to get out of that headspace when modeling for something like this. Like I had a really tough time figuring out how to connect these perpendicular plates that connected to the gearbox and the rest of the chassis. Would anybody know necessarily how to achieve maybe a more, not organic result, but something? I understand that this is maybe not the best design, but I couldn't picture another one.
Well, actually, I think your design's pretty good in that sense. Using plates is not a bad idea. To make it more organic, you can add some curves to it and some bevels and whatever. But, that if you were actually trying to make it inexpensively, you would want to do plates. Now, how do you create those combinations? Well, in the industry, one possible way they would do that is spot welding, or just something like that, and that's really not out of reach of the hobbyist. Weldments can be really cool. So that's one approach. But
yeah, eventually one of these days I will buckle down and get a welder and an angle grinder. But for right now, I was just working with Mr. V's CNC and my 3D printer at home.
Yeah. But
yeah, thing about welding though, especially if you're welding aluminum, you can put too much heat into it and warp pieces.
Yeah.
So, well, for this, on a hobbyist point of view, the cheapest way to do this, if you're going to use aluminum, is to use that low temperature aluminum rod that they have. That's I want to say it's a combination of zinc and aluminum or something. It usually has a temperature about 700 degrees. And it's like really, it's like a brazing rod. You would warm this up and then you let it flow into it, and it's stronger than the material. Just Cooper, because I think you'd find it interesting. You might go after the meeting, you might go take a look at, what do they call that? Sometimes they call it low temperature welding of aluminum, but it's not welding. It's really, like Ray said, it's a brazing process. It's also or a soldering process, depending on how you want to call it. And so what you do when you do it is you take your two pieces of metal and you warm them up, okay, and then you take your filler rod, and while it's warm, you let it flow. When it hits a certain temperature, it'll flow into into the crack, and you know, you can go to Harbor Freight and get you a pack of them for $18, and you can probably do that. Yeah, and you can probably do this on Amazon even cheaper, but you have to be careful with Amazon. There's somewhere on YouTube, there's a person who has evaluated the various ones, and he actually evaluated probably, and he actually liked one a lot better. He liked the Holbert brand of this low temperature aluminum, whatever you want to call it, brazing rod. But within his top three was Harbor Freight. Harbor Freight actually did surprisingly well with all of the tests. This guy, he does a lot of testing on it, you know, like he breaks them left, he breaks them right, you know, he smashes them all up. He does all sorts of stuff to test strength and whatnot. And, you know, he has a whole series. This is just one item that he did. And I remember Holbert was number one, and I know that Harbor Freight was number three. Now I want to say Blue Demon was number two, but that might have been number four. So anyway, it's something to look at as an alternative. If you just cut your plates, you got to get them to the right angle. You know, you have to be able to brace them. And bending, you know, bending is not a bad idea too. And I don't know if you have access to a brake, what do they call it? A brake?
Yeah.
If you have access to a brake, you know, that's between those three tools, you know, being able to cut the plates, being able to bend them, and also being able to stick them together, you're golden.
Oh, yeah.
Now, if you want to put another thing,
have certain alloys though to do that. I know. I forget which one it is. 63
is 63 is the most common, I think. Or 61.
Yeah, I think 61 is kind of brittle. If you stick it in a brake press, it may just fracture.
That's why I've kind of avoided, like, whenever people come to me and asking about, like, working on projects, and I always shy away from bending aluminum. It seems like it is more detrimental than not. But if there are certain alloys that I can controllably, use that are bendable, like you said, 6063 is, then that might be something to look at.
But the thing you have to realize when you bend, you have to calculate into your bend radiuses. So it's a much more difficult than just putting two plates together.
This old Tony has a great video on calculating bend radiuses using the machinist's handbook. That I've watched a couple times.
And also, another thing is, most people make plates way too thick. I mean, if you think about, once you start sticking these things into weldments, they actually have a lot of strength. And you don't need, 1/4 inch aluminum or 1/8 inch aluminum to do a lot of jobs. You can get away with a lot thinner stuff. And one last thing, since we're all talking about this stuff, or at least I'm talking about this stuff, is another thing that a lot of people don't, you know what a pop rivet is, right?
Sorry?
You know what a pop rivet is? Pop rivet?
Yeah.
Okay. Yeah. Well, there's something similar to that called a rivet nut, where you actually do the assembly with a screw. So you put it in, and it makes it easier to take it apart. All right. So if you were thinking of using a pop rivet, you might consider use a riv nut. Just another thought.
It's like a threaded insert.
Yeah, it's like a threaded insert. What you do is you have
and a pop rivet.
You have like a pop rivet gun, except it's got a special end on it. It's called a rib nut gun, and when you squeeze it, it causes the backside to crush. But it doesn't. Since you've got your die in the inside of the thread, it doesn't deform the thread, and so now you can put a screw in it and just screw two plates together. Anyway, those are a couple of things you might find interested in doing this. That's one approach.
You could get with John Kay and do metal casting.
Yes, that's another approach. That's really, and I would just love to try that someday. Except I'm afraid that I'd burn all my toes off. But it does seem like a lot of fun.
Certainly.
Yeah. I have a quick Fusion 360 related question. Looks like, based on what I'm seeing here, you're fairly experienced with Fusion 360. What do you use to create your gears?
Oh yeah, so my gears totally. So here, they right here they are just cylinders. For the let's see, for the worm gearbox, I will say these are I didn't CAD these.
You downloaded models for those, right?
Yeah, for these. However, I do create gears every once in a while, and there is this utility. Oh, I don't have it downloaded, but there's a pretty standard gear generator.
Is it GF gear generator?
Yeah, it's a little clunky, but I have found good use out of it when I do use it.
That's what I have. I was just wondering if there was something better, because I have the same comment you do. It's a little clunky, to use.
Yeah. I think there probably are some better extensions out there, but they might be like a commercial grade.
I'm just surprised that the basic Fusion 360 package doesn't come with a gear generator included.
Right? Yeah.
That's all I complain about Fusion 360.
Is that a standard thing in SolidWorks?
I don't know. I've never used SolidWorks.
I see. I just I need to learn how to use that too, because just.
Well, actually, I do have one other complaint about Fusion 360, and that is if you're generating, they do give you the capability to generate threads, but if there's any size thread that's not included in their standard set, then you can do a little editing on the XML file that specifies the threads. And I've done it. I've generated different sizes of threads, but every time you upgrade Fusion 360, you have to go find the folder that XML file is in and manually move it to the new installed folders.
Really? Huh.
It's a pain in the ass.
Yeah, I bet.
I don't know, John, if this is of any interest, but if you were doing it on a 3D printer, there OpenSCAD, there's a gear library that's it'll do any type of gear you want, and you just specify what type of gear and the different sizes, and it will create a file suitable for 3D printing. Yeah. And I'm not sure if you can get what other file formats it does, because I don't have any other way to make it.
Right. But I've still preferred something that I can integrate into my model in Fusion 360 rather than just an STL file. Yeah, that would be useful for some circumstances.
Mm-hmm.
I'm sure there are probably independent, gear generator programs that would generate you a step file. I don't know any off the top of my head.
And another source is from RS. They're sort of like a European parts company, and they're almost every one of their vendors includes their 3D step models of their parts if you want to download it. So
the same is true of McMaster-Carr. They have 3D models for every fastener that they sell, and I've used McMaster-Carr's. I've imported their models into Fusion 360.
Yeah.
Yeah. And then I guess I got one final thing just to wrap it up, because I've been going on for a little bit here. But so this is kind of my newest design. hopefully this will be the last one, as I've recently got a job that I think is going to actually allow me to fund this thing. I mean, I've already bought the motors, so that's usually the largest hiccup when doing all this kind of stuff. And the model's not finished, but it's kind of getting there. You can kind of see where I'm going with this. It's maybe a little bit more simple of a design. I mean, these are 3 printed parts. You know, I'm using just a motor on the actual thing, connected by, you know, belts and whatnot. The one thing I was going to ask was just that. So this whole thing is, or I guess I've got 2 questions. This whole thing, I hope to mount on my wall in this orientation where this side over here is mounted to the wall. Though I do hope to mount that on a like a linear kind of system in which I can move it back and forth. So it has, so the what's the work envelope of the arm would be, you know, my whole desk. Because the kind of the final goal for this arm, because I've had problems with, you know, like, oh, what should I make it do? You know, whole 9 yards. Final goal for this arm is just to be a work light, you know, a fancy work light. But, you know, the fact is that, you know, it's going to be running off of, hopefully, it will be running off of a Raspberry Pi or a Rock, whatchamacallit, running ROS, you know, whole 9 yards. Showing the capability of my, or showing my capabilities rather. So it is still a, you know, a portfolio piece. However, I just can't, for the life of me, think of what a good linear stage for this would look like on the scales that it's going to be. For any context, I think that end to end, so the full length of the arm is somewhere in the neighborhood of about 0.6 meters. So, and this thing's going to be pretty heavy, so I'm just not sure about kind of how I should go about that linear carriage. And then the other question I had was just on this front end, and I haven't modeled this fully either. But so its work envelope would be sufficient-ish if I just had it go from, you know, on that linear carriage from one end to the other. But in the face of making it more complicated, I would really like to be able to do some nice inverse kinematic demonstrations on this thing. And for that, I kind of want a couple more you know, axes to actually like fully demonstrate that whole thing. And I was thinking, because a work light, I want to be able to point in any which way, generally, right? And I was thinking about, for the ends, either using a parallel swivel joint or an oblique swivel joint. If anybody's got any, you know, other suggestions, because I don't know. I can't wrap my head around the oblique swivel joint. It's really its own beast. This is just about as far as I've gotten. It's just a servo-based Lazy Susan kind of thing that's self-contained, so that you could, you know, in theory, you could stack one like this and then another up here on like this angle, and then they rotate. And that's that whole thing. But just I can't quite wrap my head around it. In any case, I'm just asking. Is there any other kind of system that y'all might recommend that would be more effective at pivoting the end effector more simply, maybe?
Not that I would know. Probably Kareem would be the best person I can recommend.
It's fair enough.
And you probably already talked to him about that.
I actually haven't. I need to go back and talk with him.
Well, if you're going to do something really out of the wall, you could do one of those snake robots, right? Where you have just a bunch of pivots, but then you have pulleys. Or not. You have a bunch of ball joints one on the other, and then you have a bunch of pulleys to different joints. And then depending on how much you pull the cable, you can like move it around like a snake arm.
Oh yeah, I think I have seen those.
That would be different.
Interesting.
Yeah,
I
and
think
don't,
time, but
don't let anybody diss your design for being an overly complicated work life. That's just the fun of it. You know, it's like, sure, you can probably buy something off the shelf that does what you want, but it's the fun of building something unique.
it's the fun of it. And then you do a nice enough job, it'll get shown in My Modern Net or one of those websites, Yanko Design, and then you can sell it for a couple $1,000s.
Well, let's just hope that I'm not putting in a couple $1,000s to get this thing built and operational.
Price cost, keep a good distance.
Yeah, on the worm and the worm gear, if the ratio is low, the worm gear can the worm gear can rotate the worm. So like on these motors on
You're saying the worm will turn?
yeah.
No, he's saying as the worm turns. Exactly.
Anyway, these motors, they're it's a worm and a worm gear setup, and without much force, I can still rotate the wheel there, and that's driving the worm backwards. So I don't know if you can see that or not, but I can rotate that wheel.
Oh, are you suggesting for that kind of lazy Susan joint that I could use a worm gear in there?
Well, no, I'm just saying if the ratio of the worm and the worm gear, this is the actual motor, is low, like in that case, I had a wheel mounted to this shaft. I can spin this and it actually drives. The worm is here, and it actually drives the worm or the motor shaft.
You're saying gear ratios work both ways, right? So
yeah, and if that ratio is low,
motor generator.
Yeah, it's easier to push it. So you can basically spin the motor by spinning the wheel.
Yeah, but if you're using DC motors, though, whatever motor control you're using, you can put it in brake mode, or basically if you short the armature of the motor out, it won't move very easily.
Right. What he's trying to do is to use a worm gear reduction that will stay while he moves the motor to another worm gear.
Yeah. So in that
wanting
case,
to use a high turns ratio or gear ratio so that the friction of the worm gear is such that you can't reverse drive it.
right. Yeah, if you have a nice, ball bearings on each shaft and everything's lubed up really well, it could push it or rotate it.
Well, thank y'all for
You
all
are
the-
giving me PTSD with that screen, by the way.
Sorry about that. I was trying to get some work in while I was listening to the meeting.
Yeah, it's been decades since I've looked
It's
at
been decades and it still gives me the heebie-jeebies.
But yeah, thank you for all the suggestions on that aluminum brazing. I'll definitely look into that, because that's certainly something that I think could just benefit my toolkit amazingly.
Oh yes, Carl knows. I'm a collector of skills. People think I make things and make robots. No, that's my hobby. My hobby is really collecting skills, finding out how many different ways I can use different hammers to hit particular nails and all that kind of good stuff. So all that kind of stuff is great to know. Allows you to have more interesting problems to solve. Or I think that's a good way to put that. I think that's a good way to put that. More interesting problems. Oh, yeah, problems I want to solve versus I have to solve. Okay.
Oh, good. All right. Well, thank you, Cooper. Good stuff. That was a great discussion. So, all right. So, who else would like to jump in the queue? We have an open mic night. Doug P has something. All right. Anyone after Doug?
This is very short.
Oh,
The question I had is, I I came across something that I didn't know existed. And so I was thinking, well, maybe they don't know this exists. So I'm going to share this with you. This is an AA battery. Okay. But it's really a lithium battery that's been regulated down to 1.5 volts. And
oh yeah, it's got a little DC to DC converter.
Yeah, let me, I guess. And let's see if I can show you. You see that? That's a Type C port.
Yep.
You stick
Charging
a
port.
Charging port. Now, I think there's different styles, but so I really ran these guys through the ringer, and it is a lithium battery, so you can do some stupid stuff. I mean, if you hit it with a hammer, it's probably not a smart thing. Dumping it into the pool is probably not a smart thing. You could do that with an AA battery and it wouldn't be a problem, but you drop these in there, I don't know what goes. I shorted it. One of the things I did was short it, and just to see what would happen. Yeah.
So what happened?
And one of my brighter moves, right? What happens is the protective circuit limits the current. What I was doing was thermal imaging, so I really wanted to see if this thing would get so hot that it, just made a melted mess, and then destroyed itself. It did get up to 87 degrees Celsius, so not quite boiling water, but pretty hot.
Did you look at the output of that? Is it? I found those to be a little noisy.
I haven't. That's a good point. I haven't really checked that, but I did do the MAH curve on them. And at 100 milliamps, this one did 1955, which 2000-ish. And at 250 milliamps, which I consider a heavy load for an AA battery, it actually did 1850 or something. So, or 1870, I think. So what I'm saying is they're as good as a generic AA. Otherwise, if you went out and got I don't know about Everready or one of those, or super brand ones, but if you go down to Sam's and just pick their, or buy Amazon Basic or whatever, it's about as good as that. And, they claim it's 260, but that's probably at a load of 1 milliamp or less, That's the only way you could get it up that high. But I didn't know they existed, and I was really surprised. I mean, this is, and they have a really nice curve.
It's pretty flat until the lithium goes down.
Right. Yeah. Let me jump in here.
How do they know when to switch on the regulator? Or they can't have the regulator on all the time, do they?
Yes, they do.
There might just be a single IC that.
Yeah, it's probably something. Let me.
Well, you've got basically 3-point-something volts coming out of your lithium, and so you just regulate it down to the 1.5 volts.
Yeah, there's some funny things. Okay.
Yeah.
You don't have to use the charging port. They don't tell you that, but you don't. You can literally put 5 volts across it, and it will charge right up.
Huh.
Now, you didn't hear it here in case it blows up in you, but it worked for me. No guarantee. But that's, in fact, I actually had one cell where the little charger port went bad. And I said, well, hell, I'll just throw it in a normal lithium charger and see what it does. It could just default to half charge.
So you're saying if you can't get them to catch fire, you want one of us to see if they'll catch fire.
Well, no, but I'm just saying that I can see a lot of uses for these. I guess I was shocked at how well they worked. Not.
Where'd you find it?
Off of Amazon.
Okay.
Let's see. Let me see
Actually,
if
I think
can-
the ones that stepped down were not noisy. I think it was the 9-volt one that steps up that was noisier.
Okay.
And I think if, kind of 9-volt applications, you want them pretty quiet because usually they go in meters and,
Okay, so this is kind of interesting.
Do you know which lithium technology it is?
Can you see this? Are you guys seeing where
Yep.
it says voltage versus current for 4 cells in series? Okay,
Yep.
so this is the internal resistance measurement, and you can see, it's actually has a lower internal resistance than the alkaline batteries that I was testing. And this is the 250 milliamp load. So it went out to.
We're seeing your file list, we're seeing your file list, not the JPEG.
Okay, you're not seeing the file. Hold on a second.
A note on those ones that step up to 9 volts, that noise might be typical of the kind of pump sump or buck boost converter circuitry that you see most commonly. Just like y'all have probably used those like little boards off of Amazon to boost voltages up. Those since they're RC circuits, they aren't going to produce a very pretty DC voltage, but it's roughly
I don't know why it's. You see it now?
Nope.
Okay. Anyway, believe me, it's a nice flat curve out to about 1600, and then it peters out.
Hey, Doug, do you know which lithium chemistry it is?
No, I don't know. It was real interesting to watch the protective circuit go. So like when I put it on there in the short, I was also measuring the current. So I guess you could argue it's not exactly a dead short because it went through the volt meter, through the amp meter. But what it did, initially it was 3.5 amps. And then the protective circuit, as it heated up, the protective circuit quickly popped in, and it would go down to a very low value. And then I guess it would time out, and then it would release itself, and then, it would pop back up, then it would go back down, pop up. It was bouncing all over the place. So anyway, it was kind of cool. And they're not that, I'm sure you've all played with rechargeable AA batteries. And the big problem with mercury nickel hydride is that they've got a 1.2 volt, no load open voltage. Open circuit voltage, and most of your equipment thinks 1.2 is a dead battery. So a good design will take a battery down to 0.9 volts, but most things are not designed to do that. They call anything that's 1.2 or even 1.3 is dead. So anyway.
Like
but
a
these guys,
Samsung TV remote, I think, is one of those.
Well, they're all over the place. I mean, in fact, I know my mouse is that way. I get out there, I look at it, the open voltage is, 1.3, and I said, that's not bad. Well,
but your mouse doesn't work.
But my mouse doesn't work, yeah. And when I put a new one in, it works. So I guess that's it. Anyway, I thought if you guys hadn't seen that, you might find that interesting. I sure did. Anyway, that's all.
What's the total volt amps you can get out of that compared to like a AA? Is it about the same or is it less?
Well, that curve, I showed you the internal resistance. Hold on.
How much power will it hold?
How much power will this hold?
Yeah.
That's what I said, at 100 milliamp.
I got you. I'm sorry.
Fully charged. It depends on how much current you take out of it.
Well, how does that compare to a standard AA, I guess?
I would say that it's almost the same.
Okay.
Now, if you buy a premium acrylic battery, you'll probably get 22 to 2400. Okay. But if you get a generic, I went to Harbor Freight and got these batteries, you probably get, if you're lucky, you'll get what these guys did. So, and so, I'm thinking right now, battery costs, it's surprisingly cheap. Let me say that. Hold on a second.
I just looked it up on the web. The typical AA alkaline battery has a capacity of about 2850 milliamp hours.
But that's not true. Yeah, if you really actually test them, it depends on what current they're taking them at, John.
Yeah, it's very dependent on how much current you're pulling.
Yeah, if you pull 100 milliamps out of those guys, they won't do it. Let's see if I can find.
But it sounds like from Doug's test, if you did let's say 1.8 or 1800 milliamp hours at you dropped it from maybe 1.5 volts to about 1 volt, so that's about 0.8 watt hours.
Yeah, the ones that I happen to have got are currently unavailable, so I don't have a price. But I recall it being like $10 or something like that.
Well, those actually maintain a 1.5 volt output, right? Because they're taking it down from 3.7 or something. So the voltage shouldn't tail off, right?
So you got 1.5 volts times. But you're not going to.
They tail off right at the end.
There's a brand called Bulk AA rechargeables on Amazon. It's like $19 for 4.
Okay, so maybe it's $20.
But I found a chart here that shows it's a test of several different brands of AA alkaline cells discharged at 2 amps, and they range anywhere from about 540 milliamp hours to 2800 milliamp hours at 2 amps.
At 2 amps. I've never seen a AA battery that do the internal resistance on a like I showed you on that graph. They're going to be down in the mud. I mean, I guess if you take it to 0, but if you look at it, think at 2 amps. Oh, Jesus.
Well, here, let me show you what I'm looking at.
Okay.
But seems high.
That's my point. You're not going to take it down to 0, right? To Doug's point, it might go from full charge down to 0.9 or a volt.
E2. What's E2?
You see my screen here with the charts on it?
Yeah.
And the table of the different brands?
Mm-hmm. Yeah, you see all the ones down there around 6.3 to 9? Those are probably more realistic. I don't know what 2.8 AH is. I'd have to, let's see, what is E2? That's a lithium ion battery. That's a single-use lithium ion.
Oh, yeah. They've got one lithium ion in the table for comparison. So, as they're saying the alkaline batteries, the best performing one that they tested was 1180 milliamp hours.
But 2 amps is, 2 amps. You see where he shows them coming out at 1.25 and then dropping. See, I cut mine off at 1 volt. So when the cell goes to 1 volt, I say it's bad. See, so go back to 1 volt on that graph, and you can see that's where it is. So you're talking 0.3. So that's very short. Now, if you slide down, you can see that he goes to 500. Go down. I think he goes down to 200 and 100. Let's see. Okay, so that is what I would. That's a reasonable graph.
Yeah, that's
100
probably
milliamps.
realistic.
Yeah, 100 milliamps. He's dropping down. Now you got to come back to the 1 volt range because he's letting them go a little bit further. And you can see that's 1.8, and one of them looks like he's right at 2.1. So that's and that is probably what I would consider normal for the problem when you go up to like it's the internal resistance of the thing. If you go to 500, let me see if I can find that.
Yeah, well, 1 amp is a lot to ask of a AA battery.
Yeah.
Right. Yeah. And that's why I said, if you go to, let me share, John, for just a second. See if I can get this to work.
Okay.
Okay.
You have the floor.
I'm going to do this. This is the only way I can get it to share, I think.
There you go.
Okay, well, let's see here. All right, so here's what I saw at 250. Okay, now this is, you got to remember, this is 4 cells together. So 4 volts is where I cut it off. All right, so that's where he's doing at 250. And I gave you the values at the 1 cell, which were at 1 volt, and there are like 1950 to 1975. And this is why I don't believe kind of their stuff. So here, this is the acroline. All right, so this is 4 acroline batteries in series. So, and I took it to 0.5 amp, and they're already dropped down to 4.9. And I think if you went to 2 amps, they'd be down in the mud. Well, you can kind of project, this guy would be going like this, he'd be about here for 0.6, and then probably, so what is that? He lost 0.3 of a volt and 0.1. So I'd say at 1 amp, they'd be below 4 volts.
Yeah, I have read a couple of articles that claim that most especially most lithium-ion battery manufacturers wildly exaggerate their capacity.
Oh yeah, this guy, the guy I bought these from, he's saying 2,600. And like I say, the only way I could get 2,600 on this thing is probably, is like, a half a milliamp coming off of it, where, a constant load of a 0.5 milliamp or something like that. That's the only way I think you could get it up even close to that value.
And it's probably the absence of a standard that everybody follows for how much, what is your rating at a specified current?
Well, and the other thing is they degrade over time and use. So, once you start using them, you lose capacity.
Yeah.
Well, I mean, I'm talking about a brand new battery out of the box. They're exaggerating their capacity.
Yeah.
And this, like I say, I would think that at least at this point, this is very similar. Since I'm using a cutoff voltage of 4 or 1 per cell, if I took it down to 0, I could add a little bit more to it. But what I'm saying is that's 100 milliamps. That's reasonable. That's kind of like what you would expect for a normal use out of an AA battery. 100 milliamps or less. You know what I'm saying?
Yeah.
Or less. You think about it even if you got 2,200 out of it, and you went and you pulled out of a 250 milliamp load, that's 10 hours of life on the battery, which is probably, I would imagine the only thing I can think of that's that hard on a battery, is the old PowerShot cameras. You know, I had these old cameras
I can't imagine how hot an alkaline battery would get at 2 amps.
Yeah. I don't know. Yeah. I don't know either. I didn't, you know, like I said, I actually shorted this guy, so I can tell you what he got at the regulator chip up in the top. He got pretty hot. He got to 100. He got to 85C.
But you got to ask yourself if when use cases are drawing big slugs of current like that, 2 amps. You got to ask yourself, is it really continuous, like a flashlight, or is it more going to be like surges? So let's say you've got the old Kodak digital camera, and it's got to cycle through all the CDs on the sensor. So it's like 2 amps for a very short time, and then it's back to low level.
Yeah, well, I know that when I used to use alkaline batteries in my PowerShot that I just showed you, you know, I'd get maybe 50 pictures, which seems pretty crappy.
Yeah,
but, yeah.
Yeah, there was a guy that did an analysis on batteries you could get from eBay, and basically, if it had the word fire in it, they were all crap, you know. And it's like he even took the batteries apart and showed that, you know, okay, you'd have like an 1816 or 18650 battery, and like a third of it would actually have, you know, material inside of it, and the rest of it would be hollow. And you know, it was.
Yeah, I remember seeing something like that too, Ray, where well, I guess they were just talking about how you could be fleeced. You know,
yeah.
Some of them were just essentially cases, you know.
Yeah, just, you know, nowhere near the capacity that they claimed, you know.
Yeah.
4,000 milliamp hours.
Now on the other side of the coin is this is one of those this is a vape circuit, okay, that I found on the ground, and I took it apart, and it's actually got a 550 milliamp battery. I would not be surprised. Could have happened. Now that might be what you're seeing there is a 555 vape battery inside of a case, because they were making a gazillion of these suckers. So, and anyway.
So the vape pens, what do they actually have, like an electric element that heated and vaporized the stuff?
Yeah, This is all that's left of this one.
They do that ultrasonic vibration thing.
Yeah, they have a little.
Oh, they did.
That's the thing I think this is.
Okay.
See, like it looks like a little. It looks like a microphone.
Yeah, like a little piezo buzzer.
Yeah.
Yeah. Okay.
They actually have a little charging port. So you get a charging port. I don't know what these cost. Since I don't.
Yeah, I don't either.
I do. It's got a charging port. It's got a 550 milliamp lithium battery, and which would be great for sensors. And it's got whatever that piezoelectric thingy is, which I have no idea what it does.
Could you use that that USB port as a like a USB breakout, possibly?
Oh, like a 5-volt output? Yeah, probably not.
It has three things coming off of it: B plus, B minus, battery plus, battery minus, and something called D plus, and that they're fed into this little thing that looks like a microphone. So, and I believe it also goes to the filament thing. That's,
I wonder if the D stands for diaphragm.
I don't know. Who knows?
Well, my strategy on batteries is if you're unsure of if you don't trust the rating on the batteries, just go for overkill. So I like powering these projects with I have these talent cell lithium-ion battery packs. This one's supposedly, this one's 11,000 milliamp hours at 12 volts.
Yeah.
And it's a pretty nice little package because you got a 9-volt. You got a 9-volt output, a 12-volt output, and a USB 5-volt port on it.
So you charge it up and then you have a 12-volt output, or is that just a 12-volt input?
No, it's 12 volts or 9 volts out. You could use either one, or you can power if you can power something off the 5-volt USB. So you basically can power 5, 9, or 12 volts with this battery pack.
Yeah. Yeah, I got an OtterBox battery pack that I really like, and it's got, you know, I use it on when I travel or go hiking. Yeah. Yeah. Does anybody vape? Do they know what these things cost? I'm just curious.
I don't, but they're dangerously cheap. I can say that much.
Are they?
I can swear I've seen them for 10 or 20 bucks. Not because I vape, but because I was planning to put smokestacks on a robot.
Well, like I say, I haven't. I think to charge the battery up, I think all I did was plug it in. You know, so it's got a charging circuit on it, and it looks like it might have a PCB stuck to the top of the battery, which might be the protection circuit. I don't know. Cool.
Carl, maybe you should build a steam-powered robot.
There you go. I think that would be the next thing, wouldn't it? The next big thing.
Yeah.
Or a robot that's powered by one gigantic spring that you wind up.
Do it. Although the generator part, I don't know.
That's one big spring.
Yeah.
All right, guys.
Well, that's pretty cool. We've been losing a few people peeling off here. So, what else is on the topic for tonight? Doug D, good to see you.
Got a
report?
Been busy?
I have been busy, not so much on roboting stuff. I've been off doing other things, but I have been planning something that I probably shouldn't say anything about because I'm not very good at completing these things. I have a very ambitious robot project in mind.
Cool.
All right.
I saw plans for making a K9 robot from Doctor Who.
There you go.
And I'm going to a steampunk convention in December in Galveston.
Excellent.
If you know what that is.
I'm
yeah. Well, something
and
on
so
the street.
I'm thinking, what do I do? And I'm going to make a robot dog, not exactly K9, that looks like a backpack, deploys itself to the ground, can roam around and follow me and that sort of stuff, and reattach itself back to the backpack. And all of that's way more than I've ever done. I know the theory. We'll see if I can pull it off. I've yet to make a robot myself that actually rolls on its wheels. So it's very ambitious for me.
But see, now that you've told us, we're your motivation because we can keep asking you, how's that project going?
Now I'm kind of forced to do something.
Oh yeah, Doug.
Maybe I'll have some
We're gonna
updates.
shame you like you've never been shamed. I'll tell you
That's right. I'm easy at that.
Steampunk K9. I'll give you some advice on the brass leafing.
Okay. I've got some plans. I've been thinking about a lot of the details. I just need to start implementing.
Doug, just for inspiration, if you go out on DPRG clips, you know, that's the DPRG YouTube, and look for the title K9 Visits DPRG. And there was a guy at the Dallas Makerspace who made one. I think he was used in a play or something that they were doing, and he did it. I mean, it's a standard K9. You know, it's K9.
Right, the shape.
But you might find it was cool to look at.
Yeah.
He did a good job.
Pretty much all RC controlled, right? Not autonomous at all.
No, it wasn't. It was, I don't know if it was RC, it might have been Bluetooth, who knows, but it wasn't autonomous. But in fact, as far as I know, maybe all it did was, go in a straight line, and he just pretty much, because, they didn't need much for the play.
Yeah.
But he did put a lot of work in it, and put a lot of the details that he could have got by without. He put in. I remember it had these e-readers on the side that kept doing the white, what do they call that? Inkless paper.
E-ink display.
E-ink.
Yeah, e-ink. Yeah, they had that, for the displays, and it was doing all of this. Oh, it was really good. Anyway, if you get a chance, go take a peek at it. Just K9 on DPRG clips.
Yeah, I'll take a look. I had seen somewhere about a month ago something. It may have been, the same guy. It showed how he made the K9 and had all the original stuff on it.
Mm-hmm.
Mine's going to look more like a box because it has to look like a backpack when it's on my back with a dog head. Looky here, sticking out the top, and it deploys its tail when it gets on the ground. It has to deploy antennae with some flags on it because there's a big crowd there. I don't want it to get stepped on. It's going to be about probably 12 inches tall. It's going to have legs that are going to have to deploy themselves. Very ambitious plan. We'll see how it works.
Cool.
We'll at least cheer you on. And if you need advice, just ask questions and we'll make up answers.
That's what I'll do.
That's cool.
Just think about the thumbs up you'll get when you finish.
That's right.
Yeah, for a gold star.
I've thought for 5 or 6 years now that the club needs a good steampunk robot. So
there you go.
I'm really pleased to see something.
Yeah, Carl, didn't you kind of steampunk one of the club robots?
I started down that path. Right? That's where the whole. That's where this color scheme came from. But then I got I told my one artsy cousin about it, and helped with some website stuff. Next thing I know, he sent this care package, and he had a kit where I could gold leaf and brass leaf. So basically, it's super thin metal, and you put glue down and electrostatic charge just like sucks it up to the glue, and then you press it down, and pretty soon you've got.
Actually, I have a sample here.
I can show you. I did a trial piece.
Looks like tarnished gold or brass.
Yeah. Yeah, here it is. Look at that. So this was a. This was meant to be a. The power things you plug in a cigarette lighter in a car. So this was a sample. I 3D printed it out of plastic. Okay. And then I put brass leaf on it.
Cool.
So it's not very expensive at all, but you can very quickly get a very cool looking metallic feel to things with this approach.
I'll definitely take a look at that.
Yeah. So I can send you more information on that for sure.
Right.
So I meant to do this to that robot I just picked up a minute ago, and life gets in the way, right?
Yeah, I don't see Pat on the call. He may have left early. My other interest is astronomy, and they have their meeting on this Tuesday of each night, so I have to miss this one.
Oh no!
We just got back, but I forget where I was going with that. Oh, Pat, in his honor, I'm going to be making the body of my robot probably out of plywood. And so I'll need to cover it with that leaf stuff, possibly.
There you go.
Yeah. That'd be cool. A gold robot,
Yeah.
Sort of
gold brass.
With a dog-like head.
Yeah.
You can get that leafing material in all kinds of metals. I mean,
right.
nickel, brass, copper,
gold, silver. I mean,
For the finer ornaments too, I mean, there's always also brass colored, 3D printed filament.
Right.
Mm.
Yes. Someday I may have to take up 3D printing.
So many
Hobbies,
hobbies,
so little time.
So anyway, I'll see if I can start making some progress. First step is to get the wheels behaving so that they go forwards, backwards, turn left, turn right. That's what David Anderson always says. If you can't make it move, why are you working on the other stuff?
Very nice. All right. Okay, guys. So,
anything else for tonight?
All right.
Well, then,
Just a quick question. Are you talking about the one where K9 visits DPRG?
Yes. That was the one I was talking about.
Okay.
From 2016.
Found it.
Yep.
Cool.
Hey,
and one other quick thing, I guess.
I'm going to stop the recording now.